Linked list cycle. It is given a head, the head of a linked list, and we need to determine if the linked list has a cycle in it. This is just a description, you can read about that. Okay, the logic is we will look for the loops. If there is a loop, we will return true. If there is no loops, we will return false. That's it. So the first way is we will think simple. We will go one by one, and then if we reach to our visitor node again, we will think it now it has a loop, so we will return true. If there is no loops, we will return false, right? So let's think about that first. Then where we can reduce our complexity, speed complexity. Okay, so okay, let's go to our first idea. I will create a variable, it's called current node, to make index or position or pointer something to make where we are, right? To know where we are. Okay, so now I will put in that current node head with head, and then I will create a list of list node for making history for the visitor nodes. Okay, we will go until current nodes not equal nar. If there is no current node, if it is the current node is now, we return false. That means there is no loops in this linked list. Okay, in the current nodes, after we've done one time, we will move to the another node like that. Okay, before we move, we will check if that current node is visited or not, right? Visitor nodes dot contains current node. We will simply return, hey, this one is visited, true, we are not going anywhere. So if it is not, we will make a note, hey, this one is visited, right? Like that. Dot add node. Okay, so let's see what will happen. This one is like a very simple idea. Okay, cool. So let me see with this one to be sure before we go to the another idea. Okay, cool. So I'm gonna submit this one. Okay, oh cool. So okay, now I'm gonna go to the answer again. Okay, so now if we are going down to the questions, it is saying, can you solve it using order of one? That means constant time memories. If we are thinking about the complexity, there's a time complexity or space complexity, right? Now this one is memory. That means we have to reduce our space complexity. So space or memory. So now how many memories are we using now? This one is one, this one is a constant time, and then this one is n time, right? If the list has one element, we will have one element in this visitor node. If the list has 10 elements, 10 nodes, we will have the visitor node's length is 10, right? If it is 11, we have 11, 100, and then if it is 1000, we will have 1000 visitor nodes. So that means order of n for the memory or space. So if we think about the space complexity, it is not good too much, so we will think another approach. So I'm gonna comment this one. Okay, and then we are going to use this algorithm is called FLOYD, this flux. Hair, TORTORSE, tortoise hair algorithm. So that means, I hope you all remember that story. Turtles ran slow, right? Hares or rabbits is go so fast, right? He can run so fast. So we were think about the turtles and hare. Okay, here let's see there. Okay, here, if we are standing here, turtles and hares are standing here, and then okay, we will start. At the time, tortoise is going one, slowly, and then hares or rabbits is running so fast. Why the tortoise is going one by one, the hares or rabbits can go two, right? Because he can run faster than the tortoise, right? So by doing that way, if it is a loops, the rabbits and the turtles can meet one time, right? So by using that logic, we will think about that. We will solve this problem by using that logic. Okay, I hope you guys understand what I'm saying. Okay, let's see the code first so you can see what's going on. Okay, I will create the link nodes. Turtles, TORTOISES, turtles. We will put this one head, hair. This one is like a rabbit, right? They are standing the same at the head, and then when we start, heads or rabbits will go two notes to next. Okay, when the head is going 3 to 0, the totals can go only 3 to 2, right? Okay, by doing that way, we don't have to think about where is the totals or something, because the hare or rabbit is going first. We will think about where he is going. If it is nar or something, we will stop, right? So we only think about while hare or rabbits, not now. We don't. If the head is nar, we're not going anywhere, and then we'll return false, right? If there is no loops. And hare dot next should not be nar. If it is not, there is no loops, we will return 2, right? Okay, so by going it that way, okay, at the time, okay, the race is start. At the time, TORTOISE will go to one step from its position, SE dot next, and then here we go to the next dot next, because he can run faster than the turtles, right? So okay, by going that way one time, if they meet one time, we will return 2. That means we meet at the one time, right? So now the total is here at the time. When the head is coming back, and then we will meet at the time, right? So we will meet the same. We will meet at one node, not only in this node. Whatever it is, if we meet in the same place, we can say it is having a loop. So we will return true. If it is not, we will keep going and looking for. Oh, this one should be false, right? There is no loops. Okay, cool. So I will add one more test case to be sure. Cool. So I'm gonna submit this one again. I'm not sure they are correct or not. Sometimes it is showing different percentage, but I'm not sure. Now we can reduce even the runtime actually we want to reduce the memory also was reduced. But okay, let's see here, we use one variables and one variable, right? So we don't use any list or something, so there is no order of n. Actually if we think about that, we use two variable, so just order of two. It's okay. It is a order of one, that means constant time. Now we are constant time, right? So that's probably work. Okay, so that's it. Thank you.